Hello, everyone. Hi, thanks so much for joining us today. Welcome to our July webinar. So this month we're talking about rockfall monitoring. My name is Amna Yousaf. I'm the Marketing and Events Executive here at Sensive. So as always, before we begin the webinar, I just want to have just run through a few housekeeping notes. So we'll be having a short Q&A session at the end of the webinar. So please feel free to type questions into the question box as the webinar goes along. And just to let you know, this webinar will be recorded and it will be sent out to everyone that's registered afterwards. So without further ado, I'll introduce you to our speaker today, who's James Taylor. James has a robust background in engineering surveying. He began his career at Williamson Technical Services, where he gained invaluable experience monitoring dams, cooling towers, and oil rigs. His offshore adventures included a 7-year spell as a senior offshore engineering surveyor at Global E&C, working across the North and Irish Sea regions. So, over to you, James.
Thanks, Amna. I'm James Taylor, and today I'll be taking you through Sensive's rockfall monitoring solution. Quick look at what we already offer with landslide remote condition monitoring, RCM. Then we'll see how rockfall differs to other landslide failures, how our previous experience helps informing our solution to the challenge, how we have tested it, and our ongoing and future developments. Globally, extreme weather events have become more common, with 2024 becoming a record-breaking year for heat and rainfall. In April, Dubai saw more rain in 24 hours than it does in a typical year and a half. And in Austria last year, trains were forced to a standstill 1,900 times due to weather-related events. One consequence of this is the increase of landslide events interfering with infrastructure. So having a warning system in place is crucial. Due to developments and innovations, Sensive's method of capture and warning for slope failure has evolved to the point where there is high industry confidence in the system across many sectors. There are 45 kilometers of slopes currently being protected by InfraGard. Asset owners are alerted when failures happen through remote condition monitoring, RCM, supported by InfraGard intelligence. Here's a brief video to show how the current slope monitoring looks in practice. InfraGard is an intelligent wireless monitoring solution designed to provide asset owners with near real-time alerts. It works in the background and detects movement as it happens, regardless of when the static samples are scheduled. So if a system is reading every half hour and movement happens in between these samples, InfraGard will override and send out alerts. It's got sudden movement detection, network triggering, dynamic sampling, and alarm escalation. This is essential to detect sudden slope failures, as seen in the images on the right. Rockfalls are abrupt movements of geological materials which become detached from steep slopes or cliffs. Separation occurs along fractures, joints, and bedding planes and is strongly influenced by weathering and the presence of water. A fall-type landslide results in a collection of rock or debris near the base of a slope, potentially causing a hazard to infrastructure. As we know, a lot of infrastructure travels along the bottom of valleys, and so they are in the firing line. Unlike other types of landslides that can be monitored through Sensive's slope monitoring solution, rockfall is sporadic and could be one rock falling down a slope, missing the monitoring stakes and landing on the road or rail track unnoticed. Sensieve has gained experience in protecting infrastructure from rockfall through numerous projects, including monitoring larger rocks at source with crack meters, monitoring the paths that rockfall take regularly, instrumenting the catch fences that sit between the threat and the asset. Monitoring risks at source. Where specific high-risk rocks are identified, they can be monitored with crack sensors, such as this site in Austria. One anchor is put into the bedrock and one across the fault to the rock at risk. The crack opening and closing will cause the connecting rod to move within the transducer body. Movement data is transmitted from the nodes to the gateway wirelessly and onto Web Monitor. Monitoring historic rockfall paths. If rockfalls take an obvious historic path towards infrastructure, then these can be monitored at bottlenecks with tilt meters on stakes and cameras. As seen below, Summit Infrastructure used this approach in British Columbia to monitor spring debris flows. In remote areas with no cellular signal, Sensieve's new SATCOMS unit can be used. See the previous webinar on the new SATCOMS unit for any information. Monitoring of catch fences. Catch fences are widely used to mitigate risk to infrastructure. They can be remotely monitored with tilt meters on fence posts with alerts sent to stakeholders if rocks or material build up and breach trigger levels. This site in Lend had a rockfall which triggered InfraGuard and alerted the client outside of the scheduled sampling intervals. Here at 6 AM, the normal scheduled photo was taken. Then at 9:17, a sensor feels a movement and triggers an unscheduled sample via InfraGuard. This first trigger looks to be a small pileup of stones. Then at 10:12, further samples are taken as higher trigger levels are breached and a larger mass of rock can be seen breaching the fence. This data was all relayed to the client as it happened, ignoring the scheduled sampling rates. Here, the data shows the impact of the rockfall into the fence and the quality of the image generated, where we had previously zoomed in on the slides before. The challenge. Through discussions with infrastructure operators in the US, UK and EU, a set of requirements were collated to design a standardized, cost-effective, comprehensive rockfall monitoring solution that is quick and easy to install. It must have the ability to detect football-sized rocks and confirm with image verification at 50 meters. Comprehensively cover a 100-meter length of asset. Sampling rates that can detect failures and threshold breaches as close to real time as possible, with alerts sent containing asset information, sensor readings, and images. All-weather working capacity. Online platform to view and interrogate data. Autonomous power for comms. Autonomous power and comms for a minimum of 8 years. Sensieve's solution was to take our successful monitoring approach, slope monitoring approach, and apply it to these requirements for rockfall. We add our RCM instrumentation onto new or existing fences that are built across high-risk rockfall sites. The layout seen above would entail 2 draw wires strung across the fence panels and plugged into Sensieve's 2-port crack sensor node. These will capture any smaller rocks accumulating against the fence panels. The tilt meters will be installed on the fence posts to capture any larger rock impacts. Finally, a camera will be on site and when triggered by the InfraGuard system will capture an image to allow confirmation. So the flow of things may be during a weather event, a rockfall occurs. This triggers InfraGuard and elevates the alerts to asset owners outside of the scheduled sampling. The main function of the system will be to warn of rocks interfering with the fence. Small rocks accumulating at the bottom of the fence, volume being monitored by the draw wires and triggering if levels breached. Medium rocks being caught by the fence, triggering the draw wires and tilt meters, or larger rocks breaking through the fence and triggering draw wires and tilt meters. All these will trigger images that can be used to confirm the next steps in conjunction with sensor data. We recently carried out testing of said solution with Network Rail in Winterthur, Switzerland. An 18-meter fence was set up with draw wires and tilt meters. A variety of boulders were released down the slope to thoroughly test the solution with 150, 200, 250, 300, 350, 500 and 600 mil diameter boulders. Finally, a destructive 1 meter boulder was released to test both the fence and the RCM to breaking point. Here's the camera image triggered by the 300 by 300 rocks. As can be seen here in the draw wire data, the digital signature of the rocks are seen at each impact, even with previous rocks still sitting in the fence panel. In the tilt meter data for the 300 by 300, each impact can also be seen, but as the rocks are small, the impact upon the brand new fence is minimal. Here's the camera triggering for the destructive 1 meter boulder. Now, I don't really need to highlight the impact here with the draw wires going straight into black. Needless to say, it managed to pick it up and report it back. Same with the tilt meter data, straight into black trigger. The RCM reported all data successfully and survived. And here's a video of the 1 meter boulder and the fence. As you can see, it's pretty destructive and the system survived. Testing summary. The draw wires proved to be very accurate in warning of minor to medium impacts and the gradual buildup of material against the panels. Tilt meters were excellent for warning of medium to larger impacts. And the camera verification worked for all impacts with successful infrared alert, elevation and image generation. A fence is the most comprehensive method to ensure all failures are captured. This was tested on a very robust fence as per NR design, which acted as a semi-catch fence, not just a monitoring asset. Most existing fences would be weaker, but this wouldn't affect the RCM performance and may improve it. Finally, the next stage and further development. So the further development would be our infrared development with our partners over long-term deployments. This will help in honing the use of acceleration events and impacts for the infrared triggering. Also adding more sensors into the system, such as weather stations, drainage and soil moisture sensors. This data can then be used to identify the conditions present when rockfalls occur, thus possibly helping with future prediction and proactive control measures. The use of photo monitoring using the power of the camera and Edge Hub. The battery-powered solar camera is one of Sensei's strengths, offering uncontested quality and longevity to non-DC alternatives. This means it can be deployed in remote areas and its imagery can be monitored from the same position for years, offering a long-term record of the slope or outcrop in question. Questions?
Thanks, James. Let me just let's see what questions have come through. Okay, so the first one is, what happens if the instruments themselves are destroyed? Does the client still get alerted?
Yes, the system will have a self-health check, and any instruments lost from the system will trigger alerts, which will trigger sampling and elevate that to the client.
Okay. I can only see one other question, so if anyone does have questions, please feel free to put them in the question box so we can go through them now. So the other one is, do you provide the fence?
No, Sensitive won't provide the fence. That will be in conjunction with principal contractors on a site-by-site sort of decision.
Okay, we've got another one come in. We've got a few coming in, which is good. So what is the ideal maximum length of the draw wire?
Most of the NR fence panels were 3 meters, 2 to 3 meters. So that will be the length will have to suit the fence panel. And then obviously, depending on the flexibility you want for the draw wire to trigger on, you would need that little bit more.
Okay, well, we've got lots coming in now, which is great. So it says, if it were destroyed, would that come through as a missing data alert rather than a trigger?
That can be decided by the client. So they're varying options within Web Monitor. So if that's what you'd like to be alerted on, that's what you can be alerted on.
Next one is, what equipment is required to operate the draw wires?
Just the draw wire and Sensei's 2-port crack sensor. If any extra draw wires are needed, it'll just be increasing the number of crack sensors in the system.
Okay, so another one on draw wires says, how many draw wires can be used in one CS node?
2 maximum per node. So you could have 4 on a fence panel with 2 crack sensor nodes if you wished, if you had a particularly high fence, but we think the culmination, which is what they're best for, will be at the lower side of the fence panel, and the top side of the fence panel will be covered by the tilt meter.
Okay. Someone's asked, is there any safeguard against vandalism?
Just the standard sort of, this will be on, sort of, if it's on a railway, there'll be the protection that the railway already has. So it'll be behind fence. In other areas, in mountainous areas, it would have to be a client decision on the protection.
Do you have experience in South America with your technologies?
We do as a company. I don't right now. I'm afraid, sorry. I'm sure we can reply to that person with the details of the Sensitive person in South America.
Do these monitoring systems work in heavily vegetated areas?
The vegetation won't affect the sensors, just the camera image if it's growing over the fence. So, but if you're looking for rockfall, it may not matter. You're looking for a big rock coming through a fence. So if there's a bit of vegetation in the way, I don't think it would affect it.
Someone's asked, can we use one gateway for all sensors, or do we need more than one?
There'd only be one. Well, in terms of, we're looking to do a sort of standardized off-the-shelf system. So in terms of 100 meters, it would be one gateway, yes. For customized lengths further, it would be decided on a site-by-site basis.
Okay. Have you installed any rockfall monitoring systems in open pit mining environments? What specific modifications would be required for this scale of operations?
Not that I know of, but this is based on a fence. If the fence can be built there, then the system will work in that way. If it can't have a fence, you could always have stakes with the draw wires going stake to stake, acting as a fence themselves. Or you could not use the stakes, not use the fence, and just have the stakes driven into the rock. In some of those earlier examples, we had crack meters on the rock faults. So there's a more customized version for those applications, definitely, that we can look at. If you have any queries, you can come straight to us and we can work something out.
Cool. We've got another one here that's asking, how do you handle false alarms, like animals or human intervention on the fence?
So that's where the camera is our key, our strength. The camera's high quality, so it'll generate an image, and you can decide then if that trigger is worthwhile or not from the camera image.
Okay. Someone's asked one, I think following on from the vandalism question, if the node is moved, like, would it cause an alarm? I think that's what they're trying to say.
Yeah, it would cause an alarm. So again, the camera would confirm that if it was vandalism. Again, that something that would be open to the public would need some extra, thought by the client, and we could work something out.
Okay, cool. Let me just see. So someone's asked, is there any potential to have the alerts feeding into existing online systems other than Senseive's own?
Yes, definitely. Sensive.io will push that into the client's software of choice. So yeah, definitely.
Okay, so I'll do these last two now. Can you employ the optical displacement sensor to look vertically up the rock face and still have infraguard capability?
You could. The ODS wouldn't have the infraguard itself, but if the fence is triggered, it would force a sample from the ODS as well. So even without the ODS itself having the infraguard, if the fence is triggered, it would force a reading from the ODS. I guess you're looking up at a rock face, so it will give you a change in distance. Yeah, that would work.
Cool. Okay, so the last question, how many nodes can be assigned to a single gateway?
I think there are, I think I'm not 100% sure on the absolute optimal, but we normally have one gateway for 100 meter stretch, so over 100 sensors.
Cool. All right, well, thanks, James. Thanks, everyone, for asking the questions. I see quite a few came in the end. Of course, if you have any more questions, you can just email us, info@senseive.com, and we'll get someone to get back to you. So please do keep an eye out for our August webinar. We will be announcing that one soon. Just want to say thank you again, James. Thank you to everyone who joined us, and I hope you have a lovely rest of your day. Thanks all. Bye.
Bye.